This lecture is about trees. Acknowledgement to an introduction to statistical learning with applications in R by James Witten, Dipsharani and Hesty. The trees segment the predictor space into a number of simple regions. The set of splitting rules used to segment the predictor space can be summarized in a tree. Hence, this approach is known as a decision tree method. It is simple and useful for interpretation. It provides low prediction accuracy. Combining a large number of trees can often result in dramatic improvements in prediction accuracy at the expense of some loss interpretation. What we will do is that we will consider this lecture with the use of an example of the house sales in King County, and you can find this is in Kaggle, and this contains the house sale prices for King County for homes sold between May 2014 and May 2015. So the house data has 21,613 columns, and you can 613 rows, and you can see the columns which are there. What we will do is that we'll predict the price given all these other columns like bedrooms, bathrooms, square foot living, square foot lot, floors, waterfront, view, condition, grade, square foot above, square foot basement, year built, year renovated, zip code, latitude, longitude, square foot living 15, square foot lot 15. So these are the columns that we will use to predict the price of the house. What it does in a tree is that it creates a tree based on a variable. Here the variable is grade, and when it is less than 8.5, it segregates into two regions. So this is a region 1 and region 2. So what happens is that if suppose the grade is 8, that means it will come into this region, and the value will be 437,284, that is around 437,000 dollars. So how is this calculated? So what it does is that this segment will consist of samples which have less than 8.5, and the average of these price is 437,284. Now, how good or bad it is given by the MSC, that is the mean square error, which you can see it here. Similarly, if it is greater than 8.5, that is, say suppose it is 10, then it would go into this region and the value would be predicted to be $959,962. So this is a concept. So here I have taken from ISLR, the acknowledged book. So what it does, it has two main steps. We divide the predictor space into a set of possible values for x1, x2 to xp into j distinct and non-overlapping regions. For every observation that falls into the region Rj, we make the same prediction, which is simply the mean of the response values for the training observations in Rj. That means the one that we had shown, that if the grade is less than 8.5, say suppose the grade is 7 or 8, then it would fall into this region and the value will be the mean of the samples, that is around 437,284. Now this is the regions, how it is dividing into the regions. The goal is to find the regions which minimizes the mean square error. It is a top down and a greedy approach while building the regions in the trees. This is a tree with two levels. So here there is a split with grade less than 8.5 There is another split with latitude less than 47.54. Similarly, here the split is based on square foot living less than 4185. So this is how the tree is being constructed. With three levels, it is like the grade is less than 8.5, then it goes into latitude less than 47.34, 534, and then again there is a split based on square foot living. Here also, when it is false, then it is square foot living and latitude are the two parameters which is used there. Hope you liked the lecture in in which we explained the concept of a decision tree. We will follow it up with a live example with code in Python. Thank you. Bye.